For number 2, we got f of x equals negative absolute value of x minus 3 plus 1. So again, following that same order that we talked about on the previous page, look for the parent function. Well, the parent function is the absolute value. Then we're looking for any horizontal shifts. That's that minus 3. So it's going to be a shift 3 to the right. Remember, horizontal transformations, whether it's a shift, stretch, compression, it's always going to seem a little bit backwards. So we got a shift to the right. Then we're asked to look for any stretches and compressions. There are none. Then we're going to look for reflections. Well, there's a reflection. So it's going to be a reflection over the x-axis. And then the last one, the plus 1, means we're going to shift it up 1. So, making a quick table, let's do a parent function absolute value. I'm going to do that in red. So we're going to come up with the absolute, so f of x, oh, let me change that to a different name. Let's just call it the absolute value of x, just to base it off. We don't need to give it a function name. We got x, and we got y's. Our x is negative 2, absolute value of that is 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Now for our rule, kind of going through it piece by piece, we're going to take those x and y coordinates, and we're going to go through piece by piece and identify what's going to happen to the x and y coordinates. So the first thing, shift 3 to the right. That means we're going to take each x value and add 3 to it. After that, the rest of it's a y value. Reflect over the x-axis means we're going to take the opposite of the y value, so it's going to be flipped upside down, and then we're going to take the shift up by 1, and we're going to add 1 to it. So we're going to take each of those x values, so f of x equals negative absolute value of x minus 3, and then a plus 1 on the outside. We're going to take each of the x and y values and change it in that way. So we're going to take each x value and add 3 to it. So do negative 2 plus 3 is 1, negative 1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4, and 2 plus 3 is 5. Then we're going to take each of those y values, take the opposite of it, then add 1. So 2, take the opposite, negative 2, plus 1 gives us negative 1. 1, take the opposite of it, it's negative 1. Add 1 to it, we're at 0. 0, take the opposite, well, 0 is its own opposite, it's kind of weird. Then add 1 to it, we're at 1. 1, take the opposite, so this one that is, take the opposite of that, then add 1, so we have negative 1 plus 1 gives us 0. And then 2, take the opposite of that, which is negative 2, plus 1 gives us negative 1. So if we plot these points, well, let's plot the original points first. So negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. So it's following that same V-shaped format that we're used to. For the new points, we have a point at 1, negative 1, so we'll go 1 to the right, down 1. Then we have a point at 2, 0. Then 3, 1. Then 4, 0. And 5, negative 1. So this one's going to have an upside down V shape. So you can see it's the same shape. It wasn't stretched or compressed or anything. Let me shift this a little bit so you can see it a little bit better. So it wasn't stretched or compressed or anything. It was just kind of like shifted a little bit. So shifted to the right. Sorry, yeah, to the right on your graph. So shifted to the right. And then we shift it up 1, but also reflected upside down. For the domain, this pattern should be pretty consistent now. Our x's, oops, sorry, I'm in shape mode. Our x's are elements of the reals, and we can plug in any real number we want. That's not a problem. You can do the absolute value of any type of number. The range, we're talking about the y values, so y's are elements of the real numbers, but we're not going to hit every y value. We're going to have to say our y's have to be less than or equal to 1. Every y value on that blue graph is 1 or below. So every number is less than or equal to 1. All right, for number 3, we got f of x equals negative 2 times the square root of x plus 3 plus 1. There's a whole lot going on there. So a parent function, just to start that off, that's a square root. Now, going through this in the same order, again, looking for the parent function, then look for any horizontal shifts. We got that x plus 3 in that group. So that's a shift to the left by 3. Then we're going to look for any stretches and compressions. That 2 on the outside means it's a vertical stretch by a factor of 2. Can't spell, sorry. Then we look for any reflections. That negative on the outside means it's a reflection over the x-axis, so flipping it upside down again. And then that plus 1 in the end means it'll be, a shift up 1. So we got 4 pieces here. Shifting left 3, vertically stretching it by 2, reflecting over the x-axis, shifting up by 1. So, in order, we're going to take the original x and y coordinates that we get from the square root graph, which we'll plot those in a second. We're going to shift it left 3, so we're going to take each x coordinate and subtract 3. So again, even though it's x plus 3 in the function, it's x minus 3 in the rule. Then the next part is vertical stretched by a factor of 2. So we're going to take our y values and multiply them by 2. Reflected over the x-axis, we're going to flip the y values upside down. We're going to take the opposite. Then we're going to shift it up 1, so we'll do a plus 1 on the outside. So that one, there's a lot going on in our y values. Plus 1, sorry. Okay, let's make a quick table for the square root function, the parent function. So if we're dealing with the square root of x, we choose some x values, we get some y values. Now remember, we don't want to do square roots of negative, so we'll do 0, then 1, 4, and 9, just to get a couple points under our belts, so that way it's a little easier. And then when we take the square root of 0, we get 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Now we're going to take each of those values and apply the rule to it. So we're going to take, f of x equals negative 2 times the square root, I'm going to run out of room here, x plus 3 plus 1, and we're going to apply the rule to every x and y value. So taking those x's and y's, we were told to subtract 3 from every x. So we're going to take 0, subtract 3, we get negative 3. We're told to, in order, take negative 2 times our y value, so we're going to do negative 2 times 0, well that's still 0, and then add 1 to it, and we get 1. We're going to do the same thing with the x coordinate, 1, and then we're going to subtract 3 from it, from our x coordinate, so we have negative 2. Then the 1 that's our y coordinate, we're going to multiply that by negative 2, giving us negative 2, and then add 1 to that, so negative 2 plus 1 is negative 1. We're going to take the 4, we're going to subtract 3 from that, just like we did with the other x values, and we're going to get 1. And when we take the y value, the 2, multiply it by negative 2, so that's negative 4, plus 1, giving us negative 3. The last one we have here, we're going to take 9 and subtract 3 from it, giving us 6. For the y value, we'll take negative 2 times that 3 value, so negative 6, plus 1, giving us, let me shift over a little bit, negative 5. Just because the next one, if you wanted to do the next graph, it would be, or the next point on the square root would be 16.4. That one's going to be off the graph anyway, so we're not going to bother graphing that. But let's graph the square root graph initially. So 0, 0, 1, 1, 4, 2, and 9, 3. And that square root graph looks a little something like that. Now the transformed version, we're going to do negative 3, 1, so we'll do 3 to the left, up 1. Negative 2, negative 1, so that's down here. 1, negative 3, so that's down here. And 6, negative 5, so 1, 2, 3, 4, 5, 6. Negative 5 is down here. So this graph, it's been shifted, it's been stretched, it's been reflected, it's a whole lot going on there. For time's sake, I'm going to skip over number 4, but you can check out number 4 in our answer key.